Today I'm going to discuss about CBSE Grade-10 Physics. So light reflection, refraction. So here I'm going to discuss about refraction topic. Refraction topic I want to discuss. In the previous classes I explained reflection. Now I'm going to discuss about refraction topic. Okay. So we'll see how it is, how it goes on. And in refraction topic, we'll purely discuss about refraction definition. Okay, refraction definition we'll discuss. Again, live class will be there at 9 p.m. So there, that time I'm discussing about electricity topic already. So I made a link. I scheduled the class. Those who want to attend the class, you can attend. So now I'm going to discuss about CBSE Grade-10 Physics. CBSE Grade-10 Physics, light reflection, refraction. Especially refraction topic I'll discuss. Especially refraction topic we'll discuss in the today class. So if you have any doubts, related to CBSE Grade-10 Physics, so you can message to me or you can comment. So you can, if you want any course so related to CBSE Grade-10 Physics, you can contact to this number. So here you can see that is about CBSE Grade-10 Physics. So this is the number. You can check once. So you'll get all the topics, right? So everything you'll get it from that. So now I'm explaining completely. Exclusively I want to discuss about CBSE Grade-10 Physics. CBSE Grade-10 Physics. That too refraction topic. So today completely I'll discuss about a refraction topic. So now you can see refraction. Okay. So refraction. Light refraction. So refraction is nothing but when the object is moving from one medium to another medium. If the object is moving from one medium to another medium, so the bending of the light takes place. So light ray will bend at the interference of the two media. Light ray will bend at the interference of the two media. So that is called refraction. Okay. So I am considering here. So I am taking this this is the surface. So I am taking this one medium. This is the rarer medium, and this is a denser medium. Rarer medium, denser medium. Rarer medium, denser medium. Okay, so this is the rarer medium and this is the denser medium. Rarer medium is nothing but, so speed of light is more in the medium, that is called rarer medium. Speed of light is less in the medium, that is called denser medium. Okay, so here I'm considering, so rarer medium I'm taking air. Rarer medium I'm considering air. Denser medium I'm considering the water. So we can take water. Okay, so water or glass also we can take. So we can take a glass also. So water or glass. So if the light ray is moving from, if the C, so light ray will move from rarer to denser. So I'm taking this is a rarer medium, rarer to denser. So I'm taking this a normal line. This is a normal line. So I'm considering this a normal line. Normal. Okay, so I'm taking this a normal. So this is the incident ray. So I'm considering, so after refraction, light ray will pass like this. It bent towards the normal line. So this is the refracted ray. So incident ray, refracted ray. So light ray is moving from rarer to denser. So it is passing rarer to denser, right? Rarer to denser. So here This is incident ray, refracted ray. So light ray is moving from rarer to denser, so it bent towards a normal line. The phenomena of bending of the light at the interference of the two media. The phenomena of bending of the light at the interference of the two media is called refraction of light. Okay, refraction. The phenomena of bending of the light at the interference of the two media. So this is the interference. So at this point only light ray is bending. Okay, so only this point, only in this point only, right? Light ray is bending. So this is the area. Only this area only light ray is bending, right? Only this point the light ray is bending, so that is the interference, that is the interference. So light ray is moving from rarer to denser, it bent towards the normal line. So incident ray, refracted ray. And the loss of refraction, loss of refraction, loss of refraction, loss of refraction. There are two laws are there. Point number one, laws of refraction. There are two laws are there. So one point is so incident ray, refracted ray, normal line, incident ray, refracted. See, live class will be at again 9 p.m. So that time I'm discussing electricity topic, completely problems we are discussing. Okay, so join to the class at 9 p.m. again a live class. So that time I will completely discuss about electricity problems. There is a series, 100 problem series, electricity problem series, it's going on. So those who are interested, those who want to join, try to join to the class, attend to the class. If you are interested, you can take the course. So course is 500 rupees. So CBSE Grade-10 Physics. So in that complete explanation will be given, all the chapters, each and every detail will be given. How many marks will come for exam, or what type of concept will come, how it will come, so how they will ask, so related to board exam manner. So which type of questions they will ask, how they will ask, how to answer, each and every detail will be given, each and every detail will be explained, right? Now, so second one is here I am taking, so incident ray, refracted ray, normal lies on the same plane. Next one, so here I am considering this angle of incidence, and this one is the angle of refraction, angle of incident and angle of incidence. The ratio of sine of angle of incidence, sine of angle of incident to sine of angle of refraction equal to constant. So this is nothing but constant I am considering, constant. Okay, so this is a constant. So laws of refraction. What are the laws of refraction? So incident ray, refracted ray, normal line. So incident ray, refracted ray, normal line lies in the same plane. So the ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. So that is nothing but n. So n I am considering. N I am considering, right? So do you have any doubts related to this one? So refraction. So here one more point, if the light ray is moving from rarer to denser, it is bending towards the normal line. If it is moving, so same light ray, if it is moves, so I am taking like this. So this is the normal line. So light ray is bending like this. So it moves like this. Okay, so this is the rarer and denser. If it is moving from denser to rarer, it moves away from the normal line. The denser to rarer, it moves away from the normal line. If the light ray is moving from rarer to denser, it moves towards the normal line. So here speed is decreasing. So here is the factor is speed. Okay, speed decreases. So in these cases, case 1 I am taking. So this is the case 1 and I am taking this the case 2. Okay, in the case 1, so speed is decreasing, that's why it's bending towards the normal line. In case 2, so speed is increasing, it moves away from the normal line. So any doubts? So children, if you have any doubts, you can let me know. So we'll discuss more points related to refraction. So okay, so if you have any doubts, you can comment. You can send in the comment section if you have any doubts. So you can see this number, this is the number. You can contact this number if you have any doubts. So if you want to take the course also, you can take the course. So this is the CBSE Grade-10 Physics by Siva sir, BTech Mechanical, 10 years experience in physics teaching. Okay, so we are talking about light reflection, diffraction. Again, live class will be at 9 p.m. Again live class. Again, okay. Again, live class will be at 9 p.m. So that time, So that time I'll be discussing more electricity problems. That time I'll be discussing more related to electricity problems, right? So this is about a refraction. So refraction phenomena I'm discussing. Clear? So I hope it is clear. Next I'm going with the next one. Next one, refractive index. So refractive index I'll discuss. Refractive index. So what is the refractive index? So we'll see now. Refractive index. Refractive index. Refractive index. So refractive index, coming to refractive index. So the refractive index, if you observe here, the speed of light in the ratio of speed of light in vacuum by speed of light in medium. So n equal to ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. So this is called absolute refractive index. 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 Okay. So we are considering absolute refractive index. Relative refractive index is nothing but, so n if you are taking V1 by V2. So 2, 1. So that is nothing but N2 by N1. N2 by N1. That is nothing but N is inversely proportional to velocity. N is inversely proportional to velocity. So here N2 by N1 comes, here V1 by V2. So this is very, very important. Relative refractive index. Based on this one, problems will come. So in the exam, definitely problems will come based on this one. So few problems will discuss. Okay. So this is the related absolute refractive index. So the ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Relative refractive index is nothing but so N2 by N1. That is nothing but V1 by V2. So the refractive index is inversely proportional to velocity. Refractive index is inversely proportional to velocity. Okay, so that is about we can see. So this is about refractive index, absolute refractive index. This is the relative refractive index. Relative refractive index. Relative refractive index. So this is about relative refractive index, absolute refractive index and relative refractive index. You got it. Clear? So do you have any doubts? If you have any doubts, we'll discuss. Next one, we'll go to the next concept. Yes. So here we are discussed definitions. We discussed laws of refraction. We discussed, and one more condition. The condition is conditions for no refraction. Conditions for no refraction. Conditions for conditions for no refraction. No refraction. Conditions for no refraction. No refraction. So when refraction does not takes place. So when it will be, so when light ray is passing, so here if you are taking, if this is the object, okay, so I'm taking this a glass slab. If the light ray is passing along the normal line, so even if you are taking, if the light ray passes along the normal line, no refraction takes place. Light ray passes along the normal line, no refraction takes place. And so refractive index of two medium is same. Refractive index of two medium will be same. Refractive index is same. Refractive index is same for two materials. Same for two mediums. Two medium. Okay, so refractive index is same for two media. So that time no refraction takes place. And one more case. So if the light ray passes along the normal line, no refraction takes place. If the light ray passes along the normal line, no refraction takes place. And refractive index of two media is same. Refractive index of two media is same. That time no refraction takes place. I hope it is clear to you all. So this is about refractive index. This is the absolute refractive index, relative refractive index, conditions for no refraction. Conditions for no refraction. And here we can go with that problems are there. So Once the problems come, so I will explain the problems. So I'll explain the glass lab now. So glass lab I'll explain. So you can see refraction through glass lab. The heading is refraction through glass lab. Refraction through glass lab. Refraction through glass lab. So this they asked for 3 marks. So this question they asked for 3 marks. Okay, in the exam they asked for 3 marks in the previous exam. So CBSE Grade-10 Physics. CBSE Grade-10 Physics. So here you can check. So 3 marks question they asked. 3 marks question. 3 marks question, very important. So you have to learn at any cost. If you are learning light reflection refraction chapter, compulsory this chapter, this topic, this diagram you have to learn. Very, very important. That much important. So now you can see I'm taking. This is the glass lab. So please do like and share and subscribe my channel. So then remaining students also they will get to know live class is going on. So I'm taking this incident ray. I'm taking the normal line. So again it is coming like this. Again it is passing like that. So this is the incident ray. So extension of incident ray. Okay. So this I'm considering extension of incident ray. So incident ray I'm taking like this. Incident ray. And this is the refracted ray. So I'm taking this refracted ray. And I'm considering this the emergent ray. And I'm considering this extension of incident ray. So this is air. I'm considering this one is the glass lab. Okay, air and glass lab. If the light ray is passing, so if the light ray is passing from air to glass, so it bends towards the normal line. If it is passing from glass to air, it moves away from the normal line. So the distance between this distance is called lateral shift. The distance between, so lateral shift or lateral displacement, we can say lateral shift or lateral displacement, we can say lateral shift or lateral displacement. So the distance between the vertical distance between emergent ray and initial direction of the incident ray, or emergent ray and incident ray, initial direction of the incident ray. So that is called lateral shift. We can say. Vertical shift means the distance between actual position to apparent position. The distance between actual position to apparent position is called vertical shift. The distance between actual position to apparent position. The distance between actual position to apparent position is called vertical shift. So here lateral displacement we are discussing. So here the distance between emergent ray and extended incident ray is called lateral shift. So incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. So here whenever the light ray is passing, so refraction takes place twice. So in the glass now, when the light is passing from incident rarer medium to denser medium, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay, so this glass lab is very, very important. 3 marks question, surely they will ask in the exam. Okay, so they will ask this question, sure. Okay, so very, very important. Note down this question. This glass lab and what exactly happens. when it is for moving from rarer to denser, refraction takes place. It bends towards a normalized, speed is decreasing. Again, it is moving from denser to rarer, it moves away from the normal line, speed is increasing. The distance between emergent ray to and incident ray is the distance between the vertical distance between emergent ray to incident ray is called lateral shift. The distance between actual position to apparent position is called vertical shift. Okay, so lateral displacement means distance between these two. Okay, so this is the incident ray direction, right? Initial ray direction. And one more condition is, so light ray is moving from rarer to denser, bend towards normal line. If it is moving from denser to rarer, it moves away from the normal line. I hope it is clear to you all. So if you have any doubts, you can ask. So next one, we'll go for one more point is there. So that is about so here normal you can see light ray moves from rarer to denser. So I'm taking here like this. I'm taking here. So generally I'm taking this rarer medium and this denser medium. Rarer medium and denser medium. I'm considering rarer medium, denser medium. So R is the rarer medium. Rarer medium, and D is the denser medium. Okay, R is the rarer medium, D is the denser medium. So if the light ray is moving from rarer to denser, so I'm taking like this. So what happens generally? It moves away from the normal line. So here is the incident ray, refracted ray. So I is the incident ray, and R is the refracted ray. So I is the incident ray, R is the refracted ray. So here you can see when the light ray is moving from denser to rarer, it moves away from the normal line. The light ray is moving from denser to rarer, it moves away from the normal line. So here you can see, so I'm taking, so here incident ray. So here in the refracted ray, light passes along the surface. So refracted ray, light passes along the surface. So this is a refracted ray. And here, so here it makes 90 degrees. So this is the incident ray. So this is the angle. Okay, angle of incident is nothing but angle C, critical angle. So here you can see, if the light ray is moving from denser to rarer, okay, so in the rarer medium, refracted ray makes 90 degrees with the normal line. Refracted ray makes 90 degrees with the normal line. So that angle is called critical angle. So here it is called critical angle. So you can see here, this is a critical angle. Okay. So if the light ray is moving from rarer to denser to rarer, so the refracted ray makes 90 degrees with normal, or refracted ray gauges along the surface, okay, along the interference. So this interference between denser to rarer to denser, though that's why, so it passes along the surface. It moves along, it gauges along the surface. It moves along the surface. It passes along the surface. It gauges along the surface. So it makes 90 degrees with the normal line. So that is called critical angle. So it makes 90 degrees with the normal line. Okay. So one more, if you are taking still if I am considering the light ray I am taking. So if you are taking light ray, so here I am raising this one because it's a critical angle, right? So this is a critical angle. So fine. So angle of incidence, whatever I am taking. Because one more light ray I am taking. So here I am taking like this from here, same. Okay. So here light ray is passing from denser to rarer. So the refracted ray makes more than critical angle, So here is 90 degrees and here is theta. So it makes more than 90 degrees. Then it will be reflected back into the same medium. So it will be reflected back into the same medium. So see in same medium it will reflect back. Okay. So that is about refracted I am considering. Okay. So this is called total internal reflection. The phenomena of okay. So refracted ray makes more than critical angle. Okay, so refracted ray makes more than critical angle. So this is the 90, so more than critical angle. Then reflected ray moves into the same medium. Reflected ray moves into same medium. The total light internally reflection takes place. Okay, the total light internally reflection takes place. That is called total internal reflection. Total light internally reflection takes place. So that is called total internal reflection. Okay, so these are the points. So rarer medium, denser medium, incident ray, refracted ray. Okay, so that is about critical angle. Next one we'll talk about ray rules of concave mirror. Ray rules of concave mirror will discuss. Ray rules of concave mirror. Ray rules of concave mirror. Concave mirror. See refractive index. So refractive relative refractive index, absolute refractive index we discussed, right? Right. Now examples. Some examples of refraction. Some examples are refraction here. So a coin kept at the bottom of the vessel. So here see refraction. This is one example I am taking. So here is one coin. So here is coin is placed. Here is coin is placed. So you are standing here. You are standing. Okay. So you can't able to see the coin initially. You can't able to see the coin. So this is the coin. Okay. Coin. Beaker. And so person, here is the person. So if the person want to see the coin, so initially he can't able to. So after that if you pour water, so water if you pour, okay. So if you pour water, so I am pouring water, then the coin position will rises. So if you are taking like this, the coin position will rises up here. So the coin position will rises up here. So it appears here. Okay, the coin appears here. So this is the distance between this is the actual position of the coin. So this is the apparent position. So we can say this is the apparent position of the coin, apparent position. And this is the actual position. Actual position this actual position of the coin, this apparent position of coin, actual position of the coin, here is the coin, and this apparent position of the coin. Okay, so actual position and apparent position of the coin you can observe, right? So now you can see the distance between actual position to apparent position of the coin. So this is the actual position to apparent position of the coin is called vertical shift. This is called a vertical shift. So this is the distance. This is called vertical shift. Okay, this is a vertical shift I am taking. So do you have any doubts? If you have any doubts, you can let me know. Check it once. Here you can observe once again. So the distance between actual position, this is actual position of the coin and apparent position of the coin. So the distance between actual position to apparent position is called vertical shift. So this apparent position, this is the actual position of the coin. Okay. So now, so the person initially can't able to see, later after pouring water. So this is the water. After pouring water, you can able to see the coin. You can able to see, okay. You can able to see the coin. So because because of refraction. So that is one example I am taking. This is one example. And one more example we can say, a lemon kept in a water beaker also, gas tumbler also. If a lemon kept in the gas tumbler also. So normally if you are taking the gas slab, if you are considering, if you are taking the lemon, if you are taking the lemon, okay. So lemon also, if you place, it appears bigger. It appears bigger. This is a beaker. So lemon kept inside of it appears bigger. You can see in front of the shop. In front of the shop, every time if you go to the shop, so in front of the shop, they'll place like this. Okay. And a thick glass slab is placed over printed letters. Thick glass slab is placed over a printed letter also. It appears, okay, letter appears a little bit slight. Actually, it is supposed to be raised up, so that is the reason. And twinkling of stars also, due to twinkling of stars. So uh, twinkling of stars is about atmospheric refraction. Atmospheric refraction. And we can see one more thing, a pencil placed in the beaker. Okay. So one more important question. Actually, this they will ask for 3 marks question. This they will ask for 3 marks question. Very, very important. Even lemon also they will ask for 3 marks. Okay, so what is the reason behind of it? So refraction. This also they will ask for 3 marks question. Very, very important. So make a note of it. Make a note of it. So learn carefully this question, coin placed in the beaker. So initially it does not appear, when after pouring water it appears. Okay, so due to refraction of light, so the coin position rises up. The coin position rises up. So here apparent position of the coin, actual position of the coin. So beaker, water, so person. So initial direction, initial position. Okay, that's enough. And next one more example also we can take. If you are taking a uh, pencil also, pencil if you place, it appears to be bent. That is also due to refraction. The diagram they will ask for 3 marks. Diagram and question also they will ask for 3 marks. Make sure that so you practice, you're practicing that question. So pencil placed. If you are placing the pencil, so I am taking the pencil here. So I'm taking the pencil here. So here beaker, water is there. Water. So I'm taking the pencil here. So here it appears bent. Okay, but actually this is the position, but it appears here. Appears to be bent. Appears to be bent. Okay. So make sure that you are practicing this question. They will ask for 3 marks. At the point of intersection, so at this place, at this surface, at the interference, so at this point the pencil appears to be bent. Appears to be bent. Clear? Yes. Next. So we'll go to the next one. Next example. Total internal reflection. So what are the examples for total internal reflection? Can anyone says total internal reflection? So shining of here you see, shining of an empty beaker, empty test tube kept in water. So air bubble, and test tube is coated with and the diamonds also refraction takes place. Right? Diamond refraction takes place. Diamond shines due to refraction and total internal reflection. Okay, so next one we'll go to the, see, lateral shift depends on lateral shift. Normally I explained in the previous class. Lateral shift depends on thickness of the glass slab, angle of incidence, lateral displacement, lateral displacement. See, very well. Sometimes this question also they will ask. Lateral displacement depends on. So note down lateral displacement. So what is the lateral displacement I am taking here? So this is the surface. So glass slab I am taking here. So this is the incident ray, emergent ray. So this is called emergent lateral shift. So this distance is called lateral shift. Lateral shift. Okay, lateral shift. So lateral shift depends on depending factors. What are those? Thickness of the glass slab, angle of incidence, thickness of the glass slab, thickness of the glass slab, thickness of the glass slab. Note down, children. And the second one is angle of incidence, angle of incidence, angle of incidence. And third point is refractive index of glass slab and wavelength of light. Refractive index of glass slab, refractive index of refractive index of refractive index of glass slab, and wavelength of the light, wavelength of the light. So 2 marks question, 2 marks question for board exam, 2 marks question for board exam, CBSE. Any doubts? If you have any doubts, you can let me know. Otherwise, we'll go to the next one. This is a lateral displacement or a lateral shift, we can say. Lateral displacement. Lateral displacement. Or lateral shift. Both are same only. No need to worry about, no need to get confused. And vertical shift depends on position. So how we are seeing. And a few points I'll explain. So few problems we'll discuss. So this is very, very important. So make sure that you are okay, write down this one. So very, very important. So very okay. Depends on lateral displacement depends on thickness of the glass slab, angle of incidence, refractive index of glass slab, wavelength of the light. So very, very important points. So whatever I am discussing now, very, very important points, highlight points. So damn sure points. So it will be helpful for a exam. Okay, so make a note of it. So just go through it. So I hope no doubts. Any doubts? If you have any doubts, you can check it once. Otherwise, I'll explain. I'll go to the next one. So problems are there. Still problems are there. We can do problems. If you have any doubts, you can let me know. So until lateral displacement we discussed. Problems we have to discuss. Problems I'll discuss in the next class. So if you like this video, please do like, share and subscribe to Student the Brand. So still you can go to my channel and watch the remaining videos also. You'll get to know. Okay, na? Thank you so much. This is your Shiva sir signing off. Thank you.